Hello, my dear lovely students. How are you? I hope you are quite well and your study is going very smoothly. Today we are going to discuss the aldehyde and ketone. This is the lecture number 4, method of preparations. First, we will discuss the hydration of alkynes and second, hydroboration of alkynes. Students, once you understand, please like, share and subscribe the channels. First, we are going to understand here hydration of alkynes. Students, hydration of alkynes follow the Marconi-Cops rules. Mark rule. Okay. Second, it will be based on the electrophilic addition reaction. So hydration of alkynes is based on the mechanism of electrophilic addition reactions. Okay. So if simply I write the reactions, you can see here CH3C triple bond CH. And if we have taken the HOH in the presence of H2SO4 and HgSO4 at 333 Kelvin, the first we will get that the CH3COH double bond CH2, and then tautomeragism will happen, and the compound will form the CH3C double bond OCH. Now, what I'm telling you is simply H plus and OH minus you have. So OH minus means nucleophile. Nucleophile will attack according to Marconi-Cops rule where the less hydrogen is there. So between the double or triple bond. So here is the what happened. OH will attack on these positions and then things will happen. And the compounds will form like that. It is simple. But okay, but we understand the, in detail the concept. Students see that the H2SO4, or you can say that the alkynes don't react directly with H2SO4. Okay, so the HgSO4, either the HgSO4 or cadmium sulfate, which have a large surface area, act as a promoters. Correct? Which accelerate the reactions of H2SO4 with the alkynes. Now, what I'm telling you that the H2SO4 has, so what you can say that H2SO4 has no effect on carbon triple bond. Got that? Okay. So now what I'm telling you, we understand through the mechanism. See that. Students, we have taken that CH3C triple bond CH. Fine. And you have the H2SO4. So H2SO4 release the hydrogens and the triple bond which act as a this is the Lewis base, right? It is a Lewis base. So basically it is a acid base reaction. The first step is the acid base reaction. Okay. Now this is a nucleophile Lewis base. It has a reachable of electrons, so it attracts the protons. And then what happens? That CH3, a vinylic cations will generate. Okay, double bond CH2, a vinylic cations will generate. Once the cation will generate, you have taken the water which contains a lone pair. So what happens? That the CH3 C double bond CH2 cations, you have taken the water. Okay, so now the water will attract this positive center, and CH3 COH H double bond CH2 will form, which is the oxonium cations will form. Okay, these oxonium cations, when the base will react, the base will attack on the H plus. Just let's example OH minus is the base. That OH minus will attack on the H plus and water will form. So what happened? The BH will remove, so that you can get here the CH3C, okay, and OH, right? So that and double bond CH2 will get that. Now students, what things will happen here? See that. Students, again, when that the H plus acid you have, that H plus will attack here, so that means there is again reachable of electrons, that this substance will attract the protons, and what happens, CH3 C, that when it will attract the proton means that the CH3 will form. It means here is a negative charge. Once the negative charge will come, the lone pair will shift here and double bond OH will form. Okay, I hope you understood here. Okay, now again that base you have taken, the base will attract the protons and you will get the acetone. Correct? So alkyne gives the acetone. Done. Now we understand through the one questions here, and you tell me what would be the, which option would be the correct. Okay, this is the questions is here. You have this is the alkyne you have taken here, C triple bond C, and here the benzene OCH, right? So we have reacted with that dilute H2SO4 and HgSO4, so that the option is here benzene, okay, C double bond O, CH2, benzene, OCH3. First option. Second, you have to tell me the which option is correct here. Benzene C, OH, CH2, and here is the benzene OCH3, and here is the C. Here is the benzene and CH2, C double bond O, benzene OCH3, and the D is here benzene, right? So CH2, CH, OH, and here is the benzene OCH3. Now you tell me which option is correct. Already you have done the mechanism, so you tell me which option is correct. Students, one thing keep in mind, in the beginning I told you that this is the electrophilic addition reactions. So students, where the electrophile will generate? At the center electrophile will generate, or at the center electrophile will generate? Obviously, students, electrophile will generate at the center, which is more stable because OCH3 is donating group. So it means what? At the center electrophile generate is more stable. Okay, so obviously this C option is going to be the correct, because see here, what I am telling you, when you have taken this compound C triple bond C and benzene again OCH3, any sol is attached here. So when you have taken the HOH, OH will attack here and the compound will form like that, C double bond C, OH, and here is the OCH3. Okay, now tautomerism will happen, and after tautomerism what would be happen here? C H2, C double bond O, benzene OCH3 will form. Okay, this is the product. Student, second preparations of this lecture is HBO, hydroboration of alkynes. Okay, students, we have done in the hydrocarbons and in the alcohols hydroboration reactions. Okay, hydroboration oxidation reactions. Students, either the hydroboration oxidation of alkene or alkynes, both are free from any type of rearrangement reactions. So hydroboration oxidation reactions is a syn addition, syn, and second is anti-mark rule, and third is free from any type of what? Rearrangement reactions. Correct? So one is a syn, second is anti-mark, and free from any type of rearrangement reactions. Let's understand the example. I'm not going to describe here the mechanism. Already we have done in the alcohols and hydrocarbons. Here is the R C triple bond CH. Here we have taken the BH3 THF. Okay. So BH3 THF, what will form? RC H double bond CH, and I write here 3B. Okay, because 3 moles of hydrogen is there, so 3 moles will form. This is called trivinylic borane. This is called trivinylic borane. So this trivinylic borane, when react with the H2O2 OH negative, and then what happen? RCH double bond CH OH will form, and the tautomerism will happen. Tautomerize will happen, and then RCH2 CHO will form. Okay, this compound will form. Now what I am telling you, that terminal alkynes will form the aldehydes, okay, and non-terminal form the ketone esters. Let's understand the one questions here, and you tell me. See, first, what I'm telling you for this logic, you see that RC triple bond Cr, and if we have taken the BH3, this is the, we have taken here non-terminal compounds, and THF, okay, and second is that H2O2 and OH negative. So what things will happen? RCH2, C double bond OR will form. That means the ketone is going to be formed. So here the ketone will form. Now question is here, students. So how you can say that the product of these reactions? Here is that A we have taken, and HgSO4 we have taken along with the dilute H2SO4, right? So B will form. B will react with the lithium aluminum hydride. C will form. C is the what? Reshmic mixture will form. My option is, here is the option A. You tell me CH3, C triple bond CH will form. This is the sorry, HC CH will form, and C CH3, C triple bond C CH3, and D PH CH double bond CH2. So students, you can tell me which option is going to be the correct. CH3 C triple bond CH, SC triple bond CH, or which option is going to be the correct? Students, you have to generate the ratio mixture. See here, if what happen, if the option C will go CH3C, and here the chiral center generate means CH2 CH3 will form H. So this compound will generate the chiral center. Option C will generate the chiral center. Okay, so this is the correct option. Student, thank you. Have a nice day. Take care.